Hello everyone, especially math enthusiasts who are watching this video. To the Honorable Mrs. Shifa Fadila Hamid MPD as the lecturer of English for academic purposes and to our esteemed fellow students. Let us introduce ourselves as Group 2, consisting of myself, Keisha Dr. Vice Moderator, Tasha Ali Farahadi, and Ahmad Hafid Ghazali. On this occasion, we will present an interesting topic entitled Implementing Realistic Mathematics Education or RME, which discusses how mathematics learning can be made more meaningful through real-life context. Without further ado, I invite my colleagues to explain the first discussion on RME.
Thank you, moderator. Okay, let's start with the background. Why is RME important? Historically, the common issue in mathematics learning is abstraction. Mathematics often feels like a collection of disconnected rules, which ultimately hinders student engagement. Students struggle with math when it feels detached from reality. Our presentation aims to explain how RME can significantly increase students' engagement and conceptual understanding. Essentially, RME offers a meaningful approach to bridge this abstraction gap by connecting math to real life. The effectiveness of RME is academically supported. Research by Doris No et al. In 2024 confirms RME's significant impact on conceptual understanding. To explore this further, let us delve deeper into what RME actually means. Simply put, RME is not about easy math. The word realistic refers to the context familiar to students, which becomes the starting point for the mathematization process. This concept emphasizes that learning begins with real-life context, situations that students already understand. Then, through the mathematization process, students gradually develop formal mathematical concepts from this familiar context. This aligns with the view of Lady et al. In Mutmainah and Karlimah in 2024, who emphasized that RME is a learning model fundamentally based on real life and the surrounding environment of the students. This process is strictly guided by the core principles of RME. The RME approach is supported by several main principles. According to Griff Major in Mustafa in 2024, there are three essential principles that guide the RME learning process. Principle 1, guided reinvention and progressive mathematization. Students must be given the opportunity to personally experience the discovery of mathematical concepts. Principle 2, didactical phenomenology. Mathematical topics are presented based on two considerations: their real-life application and their contribution to the development of subsequent mathematical concepts. Principle 3, self-developed models. The models students create themselves, like drawing or schemas, serve as a crucial bridge. This helps students move from real-life or informal situation to formal mathematics. These three principles ensure that RME is effective in fostering students as active concept discoverers. That's all from me. Next, my colleague will explain. Thank you.
Thank you, Hafid. Before we move on to the advantages of implementing RME, let's pause for a moment. Have you ever wondered why many students can memorize formulas but still struggle to understand mathematics? This happens because mathematics is often learned through memorization rather than understanding. That is why an approach such as realistic mathematics education is needed. So, what advantages does RME offer in mathematics learning? According to Grave Major, RME has several important advantages. The first one is makes mathematics more meaningful. RME helps students see mathematics as part of real life, starting from familiar situation. Through real-life context, students develop a deeper conceptual understanding and learn not only how to solve problem but also why the solution makes sense. And the second one is encourage active student involvement. Through RME, students are actively involved in solving problems by exploring tasks and discussing ideas. This process encourages creativity, independence, and active thinking, making learning more engaging and student-centered. And the third one is support diverse ways of thinking. RME allows students to use different strategies and strengthen collaboration through discussion so they can learn or they can appreciate different perspectives. And the last one is build communication and reasoning skills. RME develops students' communication and reasoning by encouraging them to explain, justify, and reflect on their solution, while also strengthening mathematical modeling and higher level thinking skills. Here, as shown in the table, previous research consistently indicates that RME positively affect both cognitive abilities such as understanding and problem solving and higher order thinking skill, including creativity and critical thinking. Now, let's take a look at the step for implementing RME in the classroom according to Desi and Suharto. The first step is understanding the contextual problem. To begin the lesson, the teacher presents a real-life situation that is familiar to the student. Through this situation, students observe what is happening and connect it to their daily experiences so they can see the relevance of mathematics being learned. And the next steps is explaining or defining the problem. After students understand the situation, the next step is to define the problem clearly. Here, they identify the important information and discuss what needs to be solved so it can helping them organize their thinking before working on the task. And the third one is solving the contextual problem. Once the problem is clear, students start solving it using their own strategies, their own ideas. They may using drawings, tables, or simple calculation to explore possible answer, while the teacher guides the process without taking over their thinking. And the next step is comparing and discussing student answer. After the solution are found, students share and discuss their answer with the class. By comparing different strategies, they learn that the same problem can be solved in multiple valid ways. And the final steps is drawing conclusion. The teacher and student work together to draw conclusion. The informal strategies that students use are connected to formal mathematical concept, helping them to build deeper and more structured understanding. Next, my colleague will continue with the next section of the presentation. Thank you.
Okay, thank you, Tasha. Let's move on to a simple example of RME implementation. Here, the context is very familiar to students, making lemon tea. A student needs 2 teaspoons of sugar for 1 glass of lemon tea. The question is, how much sugar is needed for 3 glasses? To answer this question, there are several steps involved. First, students read and understand the given situation. They know that each glass of lemon tea requires 2 teaspoons of sugar. At this stage, students are not yet asked to calculate but rather focus on understanding the context of the problem. The second step is explaining or defining the problem. Students are asked to restate the problem in their own words. For example, a student might say, "This problem asks how much sugar is needed if we make several glasses of lemon tea." This step helps ensure that students truly understand what is being asked. The third step is solving the contextual problem. When solving the problem, students may use different strategies. Some students might take 3 glasses and add 2 teaspoons of sugar to each glass. Another student might immediately use the multiplication operation, that is 2 times 3 equals 6, which means 3 glasses require 6 teaspoons of sugar. Both methods are correct and reflect the student's mathematical thinking. In the comparison stage, students can discuss the different strategies and see that both methods yield the same result. Finally, they conclude that the per class concept naturally leads to proportional reasoning. This demonstrates how RME helps students construct mathematical meaning from real-life situations. Next, we will discuss the implications of implementing RME from various perspectives. For students, RME can enhance cognitive skills, promote active thinking, and develop reflective and collaborative attitudes. This means that students not only calculate, but also reason and communicate their ideas. For teachers, RME requires high competence in designing contextual problems. The teachers role shift from disseminator of knowledge to facilitator of learning, and assessment becomes more complex, focusing on both process and outcomes. For school or policy, RME needs longer learning time and may not be appropriate for every topic. However, RME is particularly effective at the elementary and secondary levels, where conceptual understanding is the primary goal. To conclude, RME is an effective learning model that uses real-life context to support progressive mathematization. It views mathematics as a human activity that students actively reinvent, rather than something they simply memorize. The key takeaway is that RME strengthens mathematical connection, improves conceptual understanding, and leads to better learning outcomes. However, there are challenges. RME requires skilled teachers, more instructional time, and more complex assessment methods. Therefore, the recommendation is to gradually adopt RME in schools, provide intensive teacher training, and develop strong banks of contextual problems. With proper support, RME can significantly contribute to deeper and more meaningful mathematics learning. Okay, that concludes our group presentations. We hope this discussion provides valuable insight to how mathematics learning can be more meaningful and engaging through real-life context. Thank you for your attention. We sincerely apologize for any shortcomings.